Hey everyone, it's Dr. Jess. In today's video, I'm going to discuss dimensional analysis, also called factor analysis or unit factor method, and how it can be used to solve pharmaceutical calculations. Okay, let's get started. In my previous video, I talked about ratio and proportion and how it can be used in dosage calculations. Dimensional analysis is an alternative method to ratio and proportion. If you are interested in learning more about ratio and proportion, I'll add the link for that video in the description box. Dimensional analysis uses a series of ratios and you place them in such a way that all the units that you do not want cancel themselves out and you're only left with the units that you want. So how does that happen? In order for that to happen, for the units that you do not want to cancel themselves out, one has to be at the top and one has to be at the bottom. So for example, let's say that milliliters is an unwanted unit. That means if you have milliliter at the top and you also have it at the bottom, those two units will just cancel themselves out. Dimensional analysis is very beneficial because it consolidates several steps into a single calculation. Now, let's look at the steps that are involved in dimensional analysis. The first step is you have to identify the wanted unit. And that's what they're asking you to find in the problem. So for example, let's say they're asking you for milliliter, so that's your wanted unit. The next step is to identify the given quantity and the units of measurement. So let's say in a problem, 3 liters is a given. They give you that in the problem, so that's a given. The third step is you have to identify if you need any conversion factors. And how do you do that? So in this case, if the wanted unit is milliliter, like I said, and 3 liters is a given, so now that tells you that you will need the conversion factor that says 1 liter equal to 1,000 milliliters. The next step is to set up your ratios so that the unwanted unit cancel out. And remember, in order for that to happen, one has to be on the top, one has to be on the bottom. So in this example, if 3 liters is a given, you have the ratio, the conversion factor, 1 liter equal to 1,000 milliliters, and you're trying to find milliliter. So 3 liters in 1 liter, one has to be on top, one has to be on the bottom in order for them to cancel out. And the last step, you have to multiply the numerator, you multiply the denominator, and then you divide the product of the numerator by the product of the denominator. Let's look at this problem. How many fluid ounces are there in 2.5 liters? Okay, so first we have to identify the wanted unit. So in this case, they're asking you for fluid ounce. So fluid ounce is your wanted unit. Next, you have to identify what's given in the problem. So 2.5 liter in this case is given. Third, you have to identify if you need any conversion factors. So how do you know which conversion factors you need? So in this case, they're asking you for fluid ounce. So you know you'll need the conversion factor that says 1 fluid ounce equal to 29.57 ml. Now, is that the only conversion factor that we need? The answer is no. We also need the conversion factor that says 1 liter equal to 1,000 milliliters. And why do we need that? Because one of the given quantities in the problem is 2.5 liters. The first conversion factor, 1 fluid ounce equal to 29.57 milliliters. So you have a quantity in liter, you have another quantity in milliliter. So that's how you know you'll need the conversion factor 1 liter equal to 1,000 milliliters. Next, you have to set up your ratios in such a way that the unwanted units cancel out. So first, 2.5 liters is a given. So you write that down first. Times your first ratio, 1 liter equal to 1,000 milliliters. So then you might be wondering, which one do I put on the top? Which one do I put on the bottom? Well, we know that 1 liter has to be on the bottom because we want that to cancel out with the liter from 2.5 liters. Then you multiply by 1 fluid ounce over 29.57 ml. So then you may be asking, how do I know if I put fluid ounce on top and the milliliter on the bottom? Well, in this case, again, we know in the previous ratio, 1,000 ml was on top. So then that means 29.57 needs to be on the bottom. So that way those 2 ml can cancel out. Also, we know what we're trying to find is fluid ounce. So that means that value needs to be at the top. So then you can see the 2 liters cancel out, the 2 milliliters cancel out. Now the only unit that we're left with in the problem is fluid ounce. Now, what I need all of you to do is to calculate your answer and write your answer down in the comments below. Let me know what you found. Let's look at another problem. A medication order calls for 1,000, I believe I meant to write 1,000 here, 1,000 ml of dextrose IV infusion to be administered over an 8-hour period. Using an IV administration set that delivers 10 drops per ml, how many drops per minute should be delivered to the patient? Here the same rules apply. You have to first identify your wanted unit, and that is drops per minute. That is what they're asking you to find in the problem. Next, you have to identify your given quantities, and that's 10 drops per ml, but also 1,000 ml over 8 hours. That's also a given. Next, you have to identify if you need any conversion factors. Well, how do we know which conversion factor we need? In the problem, they give you 8-hour period, but in your final answer, they're asking you to find drops per minute. So that tells you you'll need the conversion factor 1 hour equals 60 minutes. Next, you have to set up your ratios. So first, 10 drops per ml, 10 drops need to be on top because in your final answer, it's drops per minute. So that means you want your drops to be on the top. Then 1,000 ml over 8 hours, you want your 1,000 ml to be at the top because you want that ml to cancel out with the ml from 1 ml that's at the bottom. And for your conversion factor 1 hour and 60 minutes, you want 1 hour to be on top because you want that to cancel out with the hour from 8 hours. Also, your final answer should be in drops per minute. That means minute has to be at the bottom. Okay? If you've made it this far into the video, I would like all of you to like the video, subscribe, and turn on your notification bell so you can get more of my videos. And I would like everyone to calculate your answer and write your answer down in the comments below. Let me know if you have any additional questions on this topic, and I'll be more than happy to answer them. That's it for today. I'll see you all in the next one. Bye.